Sunita ma'am. Today I am teaching radioactivity. This is the first class, first part of the topic radioactivity. Let us discuss the topic. Let us study what is meant by alpha decay. Let us study what is radioactivity. Then we will come to know alpha, beta and gamma decay. Radioactivity or alpha decay. What is meant by radioactivity? Let us discuss in detail here. Everyone please start reading. They are going to recruit more number of teachers, whether it may be primary teachers, secondary teacher, even high school teachers also, even PU lectures also they are going to recruit. That's why make your study properly, at least daily, every day study at least 2 to 3 hours per day. Whenever you will get the free time, please watch my class. Not only science, even math, psychology, computer, GK, everything, at least daily one hour. Read daily, then you can clear any government teachers exam. Okay. Then let us study in detail what is meant by radioactivity. Many significant activities in nature takes place around us or unnoticed. Yes, so many significant activities it will occur in the nature. Some activities we know, someone without notice they will be going on. Okay. Important significant activities are emission and absorption. Emission and absorption are some of the phenomena that go unnotified. We can't even notify how the emission and absorption phenomenon, how it will be taking place without noticing. It will be going on continuously. When it takes place in an atom is very tiny particles, single particles. With your naked eye you are not able to see an atom, correct? No. Inside an atom, emission of electrons, even absorption of electrons, emission of electron, absorption of energy or release of energy, all the process it will be takes place inside the atom. In the last class I told, consider this is an atom, this is the nucleus. Nucleus contains proton and neutrons. Electrons it will be revolving around the nucleus. Then here you will be noticing that in an atom, electrons they will be revolving around the nucleus. Then here you are having the energy shells, energy levels. Then here the electrons they may jump from one energy level to another energy level. I will write the energy level like this. Okay, here the electrons they may jump from lower energy to higher energy. Even they can jump from lower to higher. Even they can emit, otherwise even they can come from higher energy to lower energy, like this. When the electrons when they will be moving from one energy level to another energy level, then sometime they will gain the energy, sometime they will lose the energy. That one only we will consider as a emission and absorption of energy. Okay, why it will happen? Because the electrons they will be jumping. Okay, they will move from one energy level to higher energy level. When the electrons they will move from ground energy level to higher energy level, normally they will absorb the energy because they need extra energy to jump from lower level to higher energy level. When they are coming from higher level to lower level, normally they will lose the energy, they will emit the energy. Therefore emission and absorption are the most significant activities. Daily life we are not able to see that one, but this it will happen inside the atom continuously. Then radioactivity is one such property of matter where the emission of energetic subatomic particles takes place spontaneously. But in the case of radioactivity is one of such property of the matter where the emission of energetic subatomic particles it will be takes place. Emission is nothing but liberation of energetic subatomic particles. Here subatomic particles are proton and also neutron, sometimes even electrons also. Proton, neutron, electron, we will call it as a subatomic particles in an atom. Then in the case of a radioactivity, you will observe the emission of highly energetic subatomic particles. Sometimes proton is released, sometimes neutron may be released, sometimes electron may be released. Then you can ask the next question, why this emission it will occur? What is the use? Why it has to occur? Because some atoms are unstable. Not all the atoms are not stable. Some atoms may be unstable. To attain stability, to attain stability, some atoms they will radiate subatomic particles, proton, neutron and also electron. This process we will call it as a radioactivity. In the simple word, you have to remember what is mean by radioactivity means if the atoms are unstable, to attain stability they will release, otherwise they will emit subatomic particles spontaneously without taking any without wasting any time, without consuming any energy. They will start emitting spontaneously without wasting the time. Okay, that one we will consider as a that one we will consider as a okay, radioactivity. Then you have to remember what is mean by radioactivity means the some atoms are unstable. To attain stability, they will release subatomic particles. This process we will call it as a radioactivity. Then move to the next one, next definition. What you will study in the case of radioactivity. Due to nuclear instability, yes, nuclear instability, an atom's nucleus exhibits the phenomenon of radioactivity because some of the atom of the nucleus is unstable. Even atom is unstable, you can consider. When the atom is unstable, to attain stability, it will undergo a phenomenon of radioactivity. Energy is lost due to the radiation that is emitted out of the unstable nucleus of an atom. Here, normally in the case of radioactivity, energy it will be lost. Energy is lost due to the radiation that is emitted because here the emission of radiation, otherwise the emission of subatomic particles it will take place. Normally it will lose the energy. Two forces, namely the force of repulsion that is electrostatic and the powerful force of attraction of the nucleus keep the nucleus together. Two forces, the force of repulsion that is electrostatic force. Electrostatic force is one of the example of force of repulsion, correct? No, normally two forces they will play an important role here in the case of radioactivity, electrostatic force and also the powerful force of attraction. Even repulsion force also there, even attraction force you will see in the case of a radioactivity. Keep the nucleus together. Why this force, why they will be exist? To keep the nucleus together. Okay, 1 minute. Yes, then here already I told to keep the nucleus together, two forces may be acting, the force of repulsion and the force of attraction. These two forces make the nucleus together. In the nucleus it contains protons and neutrons. These two forces make proton and neutron together. Okay, next point. These two forces are considered extremely strong in the natural environment. Even force of attraction, force of repulsion, that two forces we will consider the most strongest force in the natural environment. The chance of encountering instability increase as the size of the nucleus increases because of the mass of the nucleus becomes a lot when concentrated. Let us concentrate in this point. The chance of encountering instability. Yes, radioactivity, why it will happen? Because the atoms, before they will be unstable, once it undergo radioactivity, they will be stable. Increase as the size of the nucleus increases because the mass of the nucleus becomes a lot when concentrated. Why the atoms when they will be unstable? Because when the atoms, when because of the so many condition, they will attain an instability. Okay, but instability atoms, they will not exist for a longer time. Atoms, they will be stable, they will be neutral, then only they can exist for a longer time. That's a reason why atoms of plutonium, uranium are extremely unstable, undergo the phenomenon of radioactivity. Normally, unstable atoms, they can't exist for a long time. To that atoms to attain to exist for a long time, they need more energy, otherwise they should be stable. Okay, examples are plutonium and uranium. Next point, Henry Becquerel discovered radioactivity by accident. Who discovered radioactivity? Remember the scientist name, Henry Becquerel. That is the scientist who discovered the radioactivity. How he discovered? Accidentally he discovered. Accidentally. What will happen there? Let us discuss here. A uranium compound was placed in a drawer containing photographic plate wrapped in a black paper. By mistake, he kept uranium compound. He kept the uranium compound in a drawer, then containing a photographic plate wrapped black paper. That photographic plate is wrapped with the black paper. When the plate were examined later, okay, he kept for some days. He kept uranium compound that placed in a drawer. Okay, that drawer is fully closed. Then that drawer containing photographic plate wrapped in a black paper. Okay, then he kept that one for a longer days, few days maybe. When the plate were examined later, when he opened the drawer after some days, it was found that they were exposed. These uranium atoms, they were exposed because they were wrapped with the photographic plate. Even they will be wrapped in a black paper. This exposure gave rise to the concept of radioactivity. Then he will be thinking, why that uranium, why it is exposed. What is the reason? That if you keep that uranium compound for a long time, it should be uranium for a longer days, maybe few days. Okay, why it is exposed? What is the reason? Okay, then he come to know, he derived otherwise. He come to know gamma decay radioactivity can be seen in such a forms. Gamma decay, photons having high energy are emitted. What is mean by gamma decay? In the case of a gamma decay, photons, they will be released with the high energy. Beta decay, emission consists of electrons. In the beta decay, the electrons, they will be emitted. Then in the case of alpha decay, emission consists of helium nucleus. Let us study in detail today what is meant by alpha, beta and also gamma decay. Before that one, let us discuss the law of radioactivity. Radioactivity is the result of the decay of the nucleus. Yes, radioactivity, decay of the nucleus, the unstable nucleus, it will be converted into a stable nucleus when it emit alpha, beta, gamma radiations. Okay, that we will consider as a alpha decay, beta decay, gamma decay. The rate of decay of the nucleus is depend upon the temperature and pressure. Already I told the decay of nucleus we will observe in the radioactivity. but this decay it will be depend upon the independent of the, it will not depend upon the temperature and pressure. The rate of decay, whether the decay it will increase or decrease, the rate of decay it will not depend upon the, that is independent of the temperature and pressure. It will not depend upon the temperature and pressure. Independent, see the word independent of temperature and pressure. Radioactivity is dependent on the law of conservation of energy. This is radio decay of rate of decay that is independent of temperature and pressure. But radioactivity it will be depends upon the, that it will be based on the concept of law of conservation of energy. What is mean by law of conservation of energy? Energy can neither be created nor be destroyed. Only you can transfer the energy from one form to another form. Based on this law of conservation of energy, full radioactivity process it will occur. That's why radioactivity is depend upon the law of conservation of charge. But this one you have to remember, radioactivity it will be independent of temperature and pressure. The physical and chemical properties of the daughter nucleus are different from the mother nucleus. This I will tell later. What is meant by the daughter nucleus? What is meant by the mother nucleus? Both daughter and mother nucleus, they will show different physical and chemical properties. Daughter nucleus means, mother nucleus means this is the unstable atom you can consider, otherwise unstable. After radioactivity you will get the stable nucleus, no, both, whether after radioactivity, after the completion of radioactivity, unstable nucleus is converted into a stable nucleus. Before the unstable nucleus we will consider as a mother nucleus. What we will get, the new nucleus of an atom, that is the daughter one. But both also they will show different physical and chemical properties. With the example I will tell what is meant by daughter and mother nucleus. Next one, the emission of energy from radioactivity is always accompanied by alpha, beta, gamma particles. Yes, here the radioactivity it will occur with the emission of energy. Energy it will be released in the case of radioactivity. Here with that release of energy you will observe alpha, beta, gamma particles, they will be released. Okay. The rate of decay of radioactivity substance is dependent on the number of atoms that are present at time. Yes, the rate of decay or radioactivity substance it will be depend upon the number of atoms, how many number of atoms they will be involved in radioactivity. That one you have to remember. Then two important point you have to remember, radioactivity, otherwise the decay of radioactive substance is depend upon the number of atoms. Then it will be depend upon the law of conservation of energy. But rate of decay is independent of temperature and pressure. Why I am stretching all this? Because definitely in the exam they will ask. Then physical and chemical properties of daughter and parent nucleus it will be different. Next one, what is the unit of radioactivity? Curie and Rutherford are the units of radioactivity. 1 Curie it will be equal to 3.7 into 10 to the power of 4 Rutherford. This is the relation between Curie and Rutherford. That is the scientist name, Rutherford. Okay. Okay, let us study in detail what is meant by alpha decay. Up to now we studied in detail about what is meant by radioactivity. But now we will discuss in detail what is meant by a alpha decay. Alpha decay or alpha decay, you can use the symbol alpha like this, alpha, okay, is a type of radioactivity decay in which the atomic nucleus emits an alpha particle, thereby transforming a decaying into a new atomic nucleus. Yes, alpha decay means here the nucleus it will emit an alpha particle. The name itself is indicating alpha decay. Then the nucleus, unstable nucleus, it will emit a alpha particle. Unstable nucleus it will emit the alpha particle. That one we will consider as a alpha decay. Here atomic mass number of the newly formed atom will be reduced by 4. Very important one. Normally helium Okay, we will get the uh, daughter, otherwise new product, new stable nucleus, it will be stable atom, it will be helium. Then here atomic mass number. Okay, this I will show with the next. Okay, next I included the diagram, don't worry. Here the atomic mass number of a newly formed will be reduced by 4. Atomic number E will be reduced by 2. That one you have to remember. Atomic mass is reduced by 4. Atomic number is reduced by 2. See here, atomic number means number of proton. Number of proton. Atomic mass. Okay, the emitted alpha particle is known as helium nucleus. The emitted alpha particles we will consider as a helium nucleus. Yes, the mass of the alpha particle is relatively larger, has a positive charge. Yes, the mass of alpha particle, it will be more, it has a positive charge. Ernest Rutherford distinguished alpha decay from other form of radiation by studying the deflection of radiation through a magnetic field. How you will get whether alpha particle is released? Okay, based on the magnetic field, deflection of the radiation through a magnetic field, we will come to know. Then the deflection of alpha decay would be positive charge, as the particles, alpha particles are plus 2 E charge, positive charge. Let us include the equation, then you will come to know. Let us study in detail alpha decay equation. Here consider any X atom here. This is the atomic mass, this is the atomic number. Atomic number is nothing but number of proton. In alpha decay, the mass number of the product nucleus or daughter. This is the parent we will consider. This is the parent atom we will consider. This is the daughter. Okay, then helium, with this one helium it will be released. Alpha decay, the mass number of the product nucleus, daughter nucleus is 4 less than that of the decaying nucleus. This is the decaying nucleus. X is the some unknown atom. Okay, this it will start decaying, it will start radioactive. Then you will get this alpha. This is the alpha particle. Helium only we will consider as a alpha particle. Helium particle we will consider as a alpha particle. Then here Y we will get the daughter atom or daughter nucleus we will consider. Then here the atomic mass is reduced by 4, A minus 4. The atomic mass, this is the atomic mass. The daughter nucleus, the atomic mass is reduced by 4. Then here atomic number is reduced by 2. This is the atomic number is reduced by 2. You can see A minus 4, Z minus 2, Y. Y is the daughter atom. Then here alpha particles. You can ask one question, why ma'am here only the helium is released? Because why not another atom is released? Because here, listen here, according to the law of conservation of energy, law of conservation of energy, how much mass is converted into energy or vice versa. Okay, how much atomic mass it is loosed, how much atomic number is loosed, it has to compensate with helium atom. Here also, see here, you can observe here minus 4, atomic mass is reduced by 4. Here plus 4 means atomic mass is added. How much atomic mass is reduced? That much atomic mass is added. Then here atomic number is reduced by 2. From this helium, the atomic number is added by 2. When you will get minus 4 plus 4, you will get 0. Minus 2 plus 2, you will get 0. Then there is no alteration in law of conservation of energy, that you can balance. Correct? That's why this parent nuclei, when it will start decaying, you will get the daughter with atomic mass is reduced by 4, atomic number is reduced by 2, with the emission of alpha particle is nothing but helium. But helium, atomic mass of helium is 4, atomic number of helium is 2. Both also they will get balanced. Then here this is the parent nucleus I mentioned here. Then A is the total number of nucleons. A is the total number of nucleons as nothing but atomic mass. Total number of nucleons means number of proton plus number of neutron. Z is the total number of proton is nothing but atomic number. Then this one is the daughter nucleus. Then helium is released as the alpha particle. Understood? Why in the case of alpha decay, why the helium is why the helium is released? Because to compensate whatever the mass is reduced, whatever the atomic number is reduced, to balance that one, the helium or alpha particle is released, because to attain law of conservation of energy. Not only alpha decay, beta, gamma, all the decays, they will follow the law of conservation of energy. Then next, let us study one more example, alpha decay example. Then here consider this uranium 238. This is the parent nucleus. Then it will be split into two daughter nucleus. Split into one daughter nucleus and also with the release of alpha particles, that is helium. Then you will get daughter nucleus, that is thorium. Mass number is 234, atomic number is 90. Again you will get the original one, 90 plus 2, 92, atomic number is balanced. Then 234 plus 4, 238. See, this also it followed law of conservation of energy. Okay, this is the best example of alpha decay of uranium 238. Yes, uranium 238. This is the parent nucleus. It will split into daughter nucleus thorium with the release of alpha particles helium. Then next, let us discuss in detail what is meant by beta decay. This also very important. What will happen in the case of a beta decay? You studied in the case of alpha decay, parent nucleus, it will produce otherwise it will, after decaying, it will produce a daughter nucleus with the release of alpha particles, that is helium. That is nothing but alpha decay. What will happen in the beta decay? Let us study in detail here. Beta decay is a radioactive decay in which a beta ray is emitted from an atomic nucleus. Yes, beta ray it will be emitted. During beta decay, a proton in the nucleus is transferred into a neutron and vice versa. Very important point. What will happen in the beta decay? Proton is converted into neutron sometime. The neutron is converted into a proton. But in the case of alpha decay, only helium is released, otherwise alpha ray is released, otherwise helium is released. That one you have to remember. But in the case of beta decay, in the nucleus, one of the proton is converted into a neutron. Sometime neutron is converted into a proton. We are having two types of beta decay, beta positive decay, then beta negative decay. If a proton is converted into a neutron, that we will consider as a, if proton is converted into a neutron, that we consider as a beta plus decay. Then if neutron is converted into a proton, that one we will consider as a beta negative decay. Beta positive decay, otherwise beta plus decay, beta minus decay you can consider. But you have to remember here, in beta plus, proton is converted into neutron, beta minus, neutron is converted into a proton. That one you have to remember. Then what will happen in the beta decay? Due to change in the nucleus, a beta particle is emitted. Yes, the beta particle is high speed electrons. It is a beta minus decay, beta decay, a positron when it is beta plus decay. See, beta particles are high speed particles. What will happen in beta negative decay? Electrons are released. This I will explain in detail. In beta plus decay, positron will released. Why the electron which will released in beta minus decay means, to balance the law of conservation of energy. Even positron also, why it will released in beta plus decay to balance the law of conservation of energy. That also I will explain in detail. Beta particles are used to treat health conditions such as eye, bone cancer. What is the use of beta particles? Why we will use that one? Beta particles to treat the cancer tissues to, to treat the cancer tissues. It may be in the eye or it may be in the bone, are also used as a treasures. Let us discuss in detail beta decay example. Yes, next one, beta decay example. Let us study with an example. This one, I think this one no need. I will move to the next example. Okay, I will move with this example. Types of beta decay, beta minus decay. Let us discuss what is meant by beta minus decay in example. In beta minus or beta minus, you can indicate like this. Beta minus decay, a neutron is transferred to yield a proton. Neutron is transferred to a proton, causing an increase in the atomic number. The neutron is neutral, but the proton is positive. Yes, neutron is converted into a proton. When neutron is converted into a proton, then atomic number, it will be increased by 1. Consider inside the nucleus you are having, sorry, this is an atom, this is the nucleus. In the nucleus you are having neutron plus proton. Then here one of the neutron is converted into a proton. Assume before you are having 10 here. Then here one of the neutron is converted into a proton. Then here the number of proton it will be increases. Therefore atomic number of this atom is increases. Okay. In beta minus, a neutron is transferred into a proton, causing an increase in the atomic number. The atomic number it will be increases. Okay. Because the number of proton it will be increases. Before, if 1 is converted here, after conversion neutron it will become 9, proton it will become 11. Then automatically the atomic number it will be increased by 1. The neutron is neutral, but the proton is positive charge. To maintain the law of conservation of energy, the nucleus in the process also produce an electron and also anti-neutrino. To balance the law of conservation of energy, what it will happen? Additional electron and anti-neutrino are produced to maintain the conservation of energy. Here before you have to follow what is mean by beta minus decay means one of the neutron is converted into a proton. One of the neutron is converted into proton, then atomic number is increased by 1. To attain the law of conservation of energy, then this parent nucleus it will produce one of the one electron and also anti-neutrino. What is mean by anti-neutrino? Then you know electron is negatively charged particles. What is mean by anti-neutrino? Anti-neutrino is the antimatter counterpart of neutrino. Both of these are neutral particles with negligible mass. Even like a neutron, even anti-neutrino also it does not contain any charge. And also mass of that anti-neutrino also it will be very negligible. They interact with matter very weakly and can even pass through the entire earth without being disturbed. Mass of the anti-neutrino it will be very small. Okay. Therefore almost the behavior of neutrino and anti-neutrino behavior is almost same. I included one more definition here. Both neutrino and anti-neutrino are the subatomic particles. These are the particles. They don't possess any charge, but their masses are negligibly less. However, the key difference between antineutrino and neutrino is that neutrino is a particle whereas antineutrino is antiparticle. Okay, the behavior both the behavior of both neutrino and antineutrino, it will be almost the same, because both also they don't have any charge. Masses also it will be very negligible, but you have to remember neutrino is a particle, antineutrino is an antiparticle. To balance the law of conservation of energy in the case of beta minus decay, with the daughter nucleus it will release even electron and also antineutrino. Okay, then here consider X atom having atomic number A, then atomic mass A, atomic number Z. Then here you will get daughter nucleus, it will be atomic number, it will be increased by 1, Z plus 1, atomic number is increased by 1. Then electron it will be produced, and antineutrino also it will be produced to balance the law of conservation of energy. Example of beta minus decay include the decay of carbon 14, it will be converted into nitrogen 14. It usually occur in neutron rich nuclei. Beta minus decay, where you will see that beta minus decay, neutron rich nuclei. Why you will observe only in the case of neutron rich nucleus means one of the neutron is converted into a proton, no, that's why we will observe in that case. Okay, remember beta minus decay means one of the neutron is converted into proton, one it will be converted into proton, then atomic number it will be increased by 1. To attain the law of conservation of energy, then this daughter nucleus it will be produced after decaying. With that one it will release even electron and also even antineutrino also, that also you have to remember. Then in the case of beta plus decay, what will happen? In a beta plus decay, the proton disintegrate to yield a neutron, proton is converted into a neutron, causing decrease in the atomic number. Then atomic number it will be decreased by 1, atomic number decreased by 1, because proton is converted into a neutron, neutron it don't have any charge. The nucleus experience a loss of proton but gain a neutron. Again, according to the law of conservation of energy, the beta plus decay, in order to obey the law, it yield a positron and also neutrino, even E plus, positron and also neutrino. In the case of beta minus decay, it will produce electron and antineutrino to balance the law of conservation of energy. But in the case of beta plus decay, one of the proton is converted into neutron, the atomic number is decreased by 1 to attain to maintain the law of conservation of energy. Then here with the release of daughter nucleus, it will produce the even positron and also neutrino. A positron is the antimatter equivalent of an electron, same in all the aspect. Positron, the name itself is indicating positive charge. Electron is negatively charged particle, positron is positively charged particle, but almost the nature it will be same, both are also antimatters. Neutrino behavior is same as the antineutrino expressed in the equation. Yes, the behavior of antineutrino and neutrino it will be same, because both they will not carry any charge, mass is negligible. Okay, that is the important points you have to remember. Let us consider this example here. Beta minus decay, carbon 14, it undergo beta minus decay, you will get nitrogen 14 with the release of antineutrino and also electron. This one is beta minus decay. Carbon 10 is converted into boron 10, beta plus decay, you will get with the release of neutrino and also positron. Okay, let us discuss within 15 minutes. I will finish this one, gamma decay. I thought this radioactivity it will take 2 classes, but I can able to explain within 1 class only. This gamma decay is very easy one. Let us finish it. Okay, then for you also it will be easy. Everything alpha beta decay, it will be in the same class, then revising it will be very helpful for you. Next class I will discuss MCQ based on the topic radioactivity. Okay, if you solve the MCQs, then you can understand the concept very neatly. Okay, then what is gamma decay? Gamma decay is the emission of electromagnetic radiation of an extremely high frequency. Yes, here in the case of gamma decay you can observe the emission of electromagnetic radiation, very high energy, giving out excess energy in order to stabilize the unstable nucleus. In the case of gamma decay also, why the emission of electromagnetic radiation, why it will happen? Because to the unstable nucleus it has to radiate, otherwise it has to undergo radioactivity, then only it will become stable nucleus. You must be quite familiar with the various energy levels in an atom. The nucleus has its own energy levels. Yes, when you consider the nucleus, it contains different energy levels like this. Gamma decay is the nucleus way of dropping from higher energy level to a lower energy level through the emission of high energy photon. Gamma decay is the nucleus way of dropping from a higher energy level to lower energy level through the emission of high energy photons. Means here inside the nucleus you are having the particles or electrons, they will jump from higher energy level to lower energy level like this. From the higher energy level to lower energy level they will jump with the release of photon. Photon is nothing but packet of energy, correct? No, that we will consider as a gamma decay. The energy level transition energies in the atom are in the order of mega electron volt. Here the in different energy levels the electrons, they will jump from higher energy level to lower energy level with the release of photon I told. Then this release of energy, it will be in the mega electron volt. It will be in the order of mega electron volt. Therefore, gamma ray emitted is also a very high energy of the order mega electron volt, just like X-rays. This is similar in the case of X-rays also. The gamma ray emitted can be differentiated from X-ray only by fact that gamma rays come from the nucleus. Due to their high energy, they are extremely penetrating, thereby dangerous to biological life form. Gamma rays, they are most powerful rays because they can penetrate. I will explain in detail. This gamma rays we will use to treat the cancerous cells, because that gamma rays, they will be high, they have high penetrating power. Because of the high penetrating power, any part of the body, any organ, they can penetrate very easily. Okay, let us study with an example how this gamma emission it will occur, otherwise gamma decay how it will occur. Let us study in detail. The image below show the path taken by cobalt 60 to move from an excited state to a non-excited state. The beta decay can leave it either one of the two energy level. First beta decay it will happen, then later it will follow gamma decay. This percentage mentioned next to the beta symbol is the probability of nuclei choosing either of two paths, beta decay followed by gamma. Here you will observe here cobalt 60 is converted into nickel 60. First it will follow beta decay, then it will follow gamma decay. Then here cobalt 60 higher energy level, these are the energy level, possible energy level. Then here they mention the percentage, how much chance it will get decayed, which energy level it will go. 99.88% this cobalt higher it will move to this energy level. How much energy it has to spend? 0.31 mega electron volt. Then next energy level it will move 0.12%. Almost this one is 99%. It will, this beta decay it will be occur, but this one is very less. First it will follow this beta decay, then it will follow a gamma decay. That's why always be in the case of gamma emission, higher energy level, excited level, it will move to the ground level. Okay. Next application of gamma rays. Some of the most energetic phenomenon in the universe occur through gamma rays. Yes, almost so many phenomena in the universe, it will be based on the gamma rays. We cannot witness these events without a gamma ray detector. Without gamma ray detector, so many phenomena it will be going on in your nature. How we will detect whether it will involve a gamma emission? Because with the help of the gamma ray detector only we can identify this process. It will occur with the help of gamma emission. Okay. To address this, scientists have created a satellite called Fermi Gamma Ray Space Telescope. To address this, scientists have created a satellite. Satellite name is Fermi Gamma Ray Space Telescope that provide an unparalleled view of the universe. Yes, this satellite it will help to study the phenomena. The next one, gamma ray sensors also used in food packing, chemical industry to measure density, thickness, composition. Food packing, we will use the gamma rays. Gamma ray sensors we will use in the food packaging. Then chemical industry to measure the density, thickness, composition, we will use gamma rays. Gamma rays are used to treat certain types of cancer. This is very important one. To treat the cancerous tissues we will use, where the high energy gamma beams are irradiated on the cancerous cells to kill them. Yes, they will make the gamma rays to penetrate in your body where you are having the cancerous tissues. Then that high energy gamma rays they will kill the cancerous tissues. Most powerful technique. Then at the end of the class we will come to study what is the use of radioactivity. Americium 241 is an alpha emitter used for domestic smoke detectors in the United States. Okay. The alpha particles give out by the americium sample ionize the air in the chamber of the smoke detector, leading to a small current in the chamber. Yes, these are the few important points where we will use radioactivity. When smoke enters the chamber, it causes a drop in current, causing an alarm to go off. Although alpha particles have a very short range, they are devastating when in close contact. The next one, alpha emitters when swallowed come in close contact with tissues are deadly in such circumstances, is therefore used in assassination attempts by radiation poisoning. Even alpha rays are more powerful rays. Radioactivity normally it will be occur. Okay, these are the few uses of radioactivities. Read that one. No need to explain in detail where we will use that radioactivity. Remember that one. Next, half-life period. This one is important. What is meant by half-life period? The time taken off of the reactions to complete, the time at which the concentration of the reactant is reduced to off. The name itself is indicating half-life period, means to complete the process, to complete half of the process, how much time it will take. That is nothing but half-life period. Okay, then here this is the radioactivity atom. Then to complete half of the decay, how much time it will take, that we will consider as a half-life period. Okay, hopefully I explained few of the concept in detail, alpha, beta, gamma decay. Then to understand the concept clearly, I will solve few MCQ question based on this topic radioactivity. Once you solve the MCQ question only, then concept it will be very clear in your mind. Okay, then thanks for listening my class. I am requesting everyone please watch my videos. Don't stop reading. When they will call, when they will recruit, maybe within 2 or 3 months they will going to recruit. They will say they will release the notification. Before that one, be ready. Once the notification released, you will be not get the time to even to revise. You will not get the time. That's why now you are free. Read. Okay. Thank you everyone. Thanks for listening my class. We will meet in the next class.